This video talks about exponents and order of operations, how to evaluate exponential expressions, and later on in future videos we'll talk about order of operations. So this is going to be kind of a shorter video talking about just exponents and kind of terminology. Uh, Terminology of exponents really talks about repeated multiplication. A lot of times when we want to repeat our multiplication, we use exponents. Exponential expressions are just simply repeated multiplication of the same factor. So we're going to talk about a couple different things. We'll talk about the base. The base is one thing. The base is, for example, the 2. If we're multiplying 2 by itself, 2 times 2 times 2 times 2 times 2, 2 is the base. So the base is what's being multiplied by itself, right there. That would be the base. And the exponent itself, exponent would be the number of times that it is multiplied by itself. So this 5 right here tells us that we're multiplying the base by itself 5 times. The base is 2. That's being multiplied by itself 5 times. So 2 to the 5th power is how we describe that exponential description. 2 to the 5th power. 2 is the base to the 5th power multiplied by itself 5 times. So the base can be a number. That's one thing. Or the base can be a variable. So if we've got a variable over here, we could say here's my variable base, a times a times a times a. We've got 4 a's. The base is a, exponent is 4 because we're multiplying the base a by itself 4 times. The base is a, exponent is 4. We're multiplying a by itself 4 times, and the shorthand would be right there. A to the 4th power describes all this. A times a times a times a. And we use the shorthand just because it's very condensed. A to the 4th power describes what the base is, how many times it's multiplied by itself, and later on we can use different rules to kind of play around with those variables and numbers bases, or bases of numbers. So keep in mind, base and exponent. Base is what's being multiplied together. Exponent tells us how many times. Base is what's being multiplied together. Exponent tells us how many times. Either way, it's kind of just shorthand. These are all equivalent. 2 times 2 times 2 times 2 times 2 is 2 to the 5th power. Base is 2 multiplied by itself 5 times. In factored form, it's 2 times 2 times 2 times 2 times 2. Really long way to write it, especially when the exponents get pretty big. Exponential form is 2 to the 5th power. And we'll probably be preferentially using this 2 to the 5th power, instead of the 2 times 2 times 2 times 2 times 2 kind of factored form. So exponential form is 2 to the 5th power. Now we do have a couple special names for special exponents. If we've got special names, we've got 2 to the 1st power. Right there, exponent is 1. 2 to the 1st power, we call it 2 to the 1st power, or to the. Sometimes this is kind of shortened as to the. 2 to the 1st power. Also, if there's no exponent written, in other words, just 2, that's also an exponential term, and it's unwritten 1. So keep in mind, if there's nothing written up here as an exponent, it's to the 1st power. Usually the 1 is not written up here as well, so it could be just 2. But 2 is also an exponential term. 2 to the 2nd power, or 2 squared, is 2 to the 2nd power. 2nd power is 2 squared. Another special term is 2 to the 3rd power is to the 3rd power. Base is 2, exponent is 3, means we're multiplying that 2, the base, by itself 3 times. It's 2 cubed. And 2 to the 4th power is nothing special. And we're kind of we're describing these because, or we're giving these special names because if we've got something squared, like a 2 times 2, we've got a square. 2 times 2 gives me 2 squared, and that's the area inside of here. If we're talking about a 3-dimensional object, see if I can do a 3-dimensional object here to the best of my mathematical ability, we will draw a little cube. Not too bad. But if we've got a cube with sides of 2, 2, and 2, and 2, then we call the volume inside this cube 2 cubed, and that's why it's called 2 cubed, because if we've got 3 of these dimensions, we've got a cube. If we've got 2 of these dimensions, 2 squared to the second power, we've got 2 times 2, and it makes a square, and after that, fourth power, well, we really don't have fourth dimensions, even though SpongeBob SquarePants might tell us that we have 4 dimensions. We really don't. So that's kind of the limit of what these special words are for exponentials.